something happened in 2022 that most people completely missed. Not a headline, not a product launch, just a number quietly updated on a commodities report. The price of lithium, the metal sitting inside every electric car battery on the planet, had risen 480% in a single year, not a decade. 1 year, and somewhere inside a massive research facility in China. A team of engineers looked at that number and made a decision that could reshape the entire electric vehicle industry. Not in 10 years now, but here's what makes this story strange. The solution they landed on isn't new. It isn't exotic. It isn't rare. In fact, you've probably touched it today. It's sodium, the same element that makes your table salt salty, and what they figured out how to do with it is something the battery world has been trying to crack for decades. You need to understand why lithium became a problem in the first place, because without that context, what comes next won't feel as significant as it actually is. Lithium didn't always cost this much. Back in 2012, a ton of lithium carbonate ran around $4,450. By 2022, that same ton cost $78,300. That's a 1,654% increase over 10 years. And the industry that depends on it, EV manufacturers, battery makers, the entire green energy supply chain, had no real backup plan. They had bet everything on one element, and that element was becoming untouchable, Elon Musk noticed. He posted that lithium prices had gone to, quote, insane levels. But noticing a problem and solving it are two very different things. And this is where the story starts to get uncomfortable. Because the company that may have actually solved it isn't Tesla. It's CATL, Contemporary Amperex Technology, the largest battery manufacturer in the world. And what they quietly announced didn't just offer a cheaper alternative. It challenged almost every assumption the EV industry had built itself on. Here's the number that changes everything. A lithium-based battery pack costs roughly $111 per kilowatt-hour to produce. CATL's sodium-ion battery, approximately $15.15 per kilowatt-hour. That's not a modest improvement. That's nearly 7 times cheaper. And when you apply that to something like a Tesla Model 3 with a 50 kilowatt-hour battery pack, the difference stops being abstract and starts being the kind of number that disrupts industries. But cost is only part of the story. And honestly, it might not even be the most important part. Think about what happens to an electric car in winter. Lithium-ion batteries operate optimally somewhere between 15 and 35 degrees Celsius. Below that, range drops. Charging slows. Performance becomes unpredictable. It's one of the most common complaints from EV owners in cold climates, and it's never been fully solved. CATL's sodium-ion battery retains 90% of its capacity at negative 20 degrees Celsius. At negative 40, it still holds more than 70%. That's not an incremental improvement. That's a different category of reliability. And then there's charging speed. A Tesla Model Y plugged into a fast public charger goes from 0 to 80% in about 32 minutes. CATL's sodium-ion cell hits 80% in 15 minutes at room temperature, more than twice as fast. Now, you might be wondering if this technology is cheaper, more cold-resistant, and faster to charge. Why hasn't it already taken over? That's exactly the right question. And the answer reveals something important about how battery technology actually works in the real world. Sodium ions are larger than lithium ions. That sounds like a minor chemistry detail, but it has a real consequence. Larger ions mean more structural stress on the battery's internal materials, which means lower energy density. CATL's first-generation sodium-ion battery produces 160 watt-hours per kilogram. Mainstream lithium batteries produce between 200 and 300. That gap means a sodium-ion battery of the same physical size as a lithium-1 will carry a car a shorter distance on a single charge. But here's what most people overlook when they hear that. 160 watt-hours per kilogram is already better than where lithium was 6 or 7 years ago. This isn't a failed technology. It's an early-stage technology moving fast. And CATL knew the energy density gap would be a barrier. So they didn't wait for sodium to catch up to lithium. They combined them. Their AB battery system integrates sodium-ion and lithium-ion cells into a single battery pack, letting each chemistry compensate for the other's weaknesses. The result is a system that can support a driving range of over 3 miles, more than the current Model Y's 279-mile range, while still keeping costs dramatically lower than an all-lithium pack. That's not a compromise. That's a strategy. There's one more dimension to this that doesn't get talked about enough. Safety. Lithium-ion batteries are flammable. The chemical reactions that make them energy-dense also make them volatile under certain conditions: extreme heat, physical damage, manufacturing defects. Sodium-ion batteries are significantly less flammable. The newer formulations use a solution that is naturally fire-suppressing and stable across a wide range of temperatures. There's also an ultra-thin protective layer that forms on the anode and stays stable over time, which is part of what gives these cells their long cycle life. So you have a battery that is cheaper, faster to charge, more stable in cold weather, and safer. The obvious question is, when CATL announced they would move sodium-ion into production in 2023, not a prototype, not a pilot program, mass production, they had already built out a supply chain. They had already entered negotiations with automakers. The infrastructure wasn't theoretical, it was being assembled in real time, and yet sodium-ion batteries will almost certainly not replace lithium entirely. The more likely outcome is a split. Lithium stays in premium, long-range vehicles where energy density is the priority. Sodium moves into everyday transportation, commuter cars, urban EVs, markets where range anxiety matters less than affordability and reliability in extreme temperatures. To chemistries, to markets, coexisting. But that split has consequences that haven't fully played out yet. If a sodium-ion-powered car can meet the needs of most drivers at a fraction of the current battery cost, what happens to the price of EVs overall? What happens to the automakers who built their entire brand identity around premium battery technology? What happens to lithium mining operations that expanded aggressively during the price spike? And maybe the most interesting question of all, if the solution to one of the biggest bottlenecks in the clean energy transition was sitting in your salt shaker the whole time, what else are we overlooking? That question doesn't have a clean answer. And that's exactly what makes this moment in battery technology so strange to watch in real time. Because we're not talking about a laboratory curiosity anymore. We're not talking about a white paper that might become a product in a decade. CATL is the largest battery manufacturer on Earth. When they commit to production, the industry listens. When they start negotiating with automakers, those conversations have weight. This isn't a startup with a promising idea. This is the company that already supplies batteries to Tesla, BMW, Volkswagen, and dozens of other manufacturers. They don't announce things they haven't already stress-tested, and yet the mainstream conversation about electric vehicles is still almost entirely focused on lithium. Range improvements, charging networks, mining rights in South America and Australia. The infrastructure of an assumption that lithium is the foundation everything else gets built on is so deeply embedded that most people haven't stopped to ask whether that foundation was ever really permanent. It wasn't, it just took a price spike to make that visible. Something worth sitting with for a moment. Sodium makes up 2.3% of the Earth's crust. Lithium, by comparison, is about 0.002%. Sodium is not just more abundant, it's so common that scarcity is essentially removed from the equation. You don't need to control a mine in a politically unstable region. You don't need to worry about supply chain disruptions from a single country's export policies. The raw material is, for practical purposes, everywhere, and the cost difference at the raw material level reflects that. Lithium carbonate, the refined form used in batteries, was priced at around $570,000 per ton at the peak. Sodium carbonate, the equivalent starting point for sodium-ion chemistry, costs less than $3,000 per ton. That's not a rounding error. That's a 190 times difference in input cost before a single battery has even been assembled. Now factor in what CATL also discovered about the electrolyte, the liquid medium that ions travel through inside the battery. Because sodium has better conductivity than lithium in certain formulations, the concentration of electrolyte needed is lower. CATL estimated that reduction alone cuts electrolyte costs by around 85%. Every layer of the cost structure points in the same direction, down, but cost alone has never been enough to change an industry. If it were, we would have transitioned to renewable energy decades ago. The real friction is always somewhere else in the assumptions of engineers who trained on one technology, in the contracts already signed with existing suppliers, in the inertia of infrastructure that took billions to build and doesn't get replaced overnight. This is the part of the story that the numbers don't capture. Automakers have spent years, in some cases, decades optimizing their platforms around lithium-ion chemistry.